Have you ever been caught out in the rain? You woke up, looked outside, and asked yourself, how likely is it going to rain today? Well, students in Year 2 continue from Year 1 to look at everyday situations where probability arises using the language of chance and explaining their reasoning. So, probability refers to the likelihood of a situation occurring. It's determined by the number of times an event is likely to occur in relation to the total number of events that could occur. Unfortunately, the likelihood of a situation does not depend on what has previously happened or personal wishes. You can't just wish it to be sunny. However, students at this age do make intuitive judgments based on imagination or personal preferences, but they need to reason why. Jones, Langrel, Thornton, and Mogul pioneered a framework for assessing probabilistic thinking. Students in Year 2 are Level 1, using non-numerical subjective level of reasoning, transitioning to Level 2 of emergent thinking. Students predict the likelihood of an event based on subjective judgments by using information cues and making connections. A great group activity is to collect information about the weather for 2 weeks and comparing the accuracy of forecasts. This leads students to make their own predictions about the likelihood of rain, such as there's an even chance of rain today because if you look outside, there are some dark clouds. So, looking at the likelihood of everyday situations, we can use a simple probability scale of impossible, unlikely, even chance, likely, and certain. So, using a socio-constructivist approach enables discussion, group work, and collaborative learning to problem solve and build on prior knowledge. This introduces language and reasoning in a natural way. Once familiar with the terminology, students use the language to talk about other everyday situations. These initial understandings and experiences are stepping stones in instruction to develop their predicting skills for the instructional sequence predict, observe, explain, which is a problem solving strategy. So, some significant work by Fishbein describes an advantage of learning about probability at a young age. Students learn to deal with the fact that negative situations can be encountered and cannot be predicted so precisely. They use personal experiences and critically interpret all possibilities to decide on the most likely. From there, students problem solve and reason. This makes learning probability relevant, not only for weather predictions, but games, sports, politics, genetics, buying insurance, and many other facets in life. It develops informed decision making and intuitive thinking skills for the future. Therefore, we need to challenge students' intuitive ideas and allow them to experience instances when personal theories are proved incorrect and allowing them to make predictions and investigate various outcomes that permit children to continue to develop at their own rates.